In the next 15 minutes, you're going to be building this, an AI agent with temporal memory that actually learns. We're going to custom build an MCP using Zep AI's Graphiti framework. We're going to show you how to build this using Agent Builder as well as Agent SDK. We're going to use Neo4j to store the graph. This is not a demo, this is not a toy, it's a production-ready system that actually remembers conversation, tracks changing relationships, and gets smarter with every interaction. By the end of this video, you're going to understand why vector databases fail at scale. You'll understand the difference between file search versus knowledge search. You'll have a working memory agent in Agent Builder as well as Google Colab. And best of all, you're going to get this template absolutely for free. First link in the description. And if you are an AI agency or a technical founder, watch till the end because I'm going to reveal the #1 architectural mistake that kills 95% production AI projects and the exact production rack pattern that lets you charge 10x more. All right, my friend, let's build. What if your AI agent could remember every conversation you've ever had, automatically learn from your preference, and know exactly what was true at a specific point of time? Now, here's the problem we are solving today. Most AI agents have zero memory. Every conversation starts from scratch. They ask you the same questions over and over again, and they can't learn from mistakes, or when information changes, they can't track what was true when. The deeper question is, what if your agents could remember, learn, and evolve? So in this video, I'm actually going to show you how you can create your first self-evolving memory agent that manages your personal memory. For that, we're going to be using an external knowledge server or knowledge database using Neo4j. We'll use a custom MCP to put it all together with agentic tools to manage memory. And I'm going to give you this template absolutely for free so you can also use that and plug it into Agent Builder. Now, for all the devs out there who want to go a little bit deeper into coding, I've also built out a Google Colab notebook that you can use to practice working with agents. Everything's labeled step by step, so you can also build a memory agent alongside with me. If you're an AI agency or a technical founder, you probably face this scenario yourself when you're working with RAG systems, because most RAG systems just let you search through documents. They don't really learn, right? If you tell your AI agent, hey, I live in Tokyo, and the next month you say, I live in Bangkok, it won't be able to remember the changes in the information, right? So you can't understand the time component, and even worse, it just doesn't remember you at all. That's not intelligence, that's amnesia. Now obviously you'll probably face this scenario when your RAG starts breaking. While your knowledge base grows to 10,000 documents, traditional RAG starts choking. Long delays, wrong answers, and here's the killer: it costs 3x the development time just to debug why it's failing. The technical debt compounds fast, right? And you're also busy managing personal relationships, client projects, and then you have another RAG thing to worry about. And of course, bad data management has real-world consequences: millions of dollars in lawsuits, failed audits, production disasters, and destroyed reputation, right? So if you're working in the field, you'll know how important that is. So that's one thing that you need to really focus on right now rather than later to really make sure all the boxes are ticked. And another benefit of knowledge graphs is that it tracks changes in information. So if a client changes their budget or a contact person switches, your system has no idea what was true when, right? So these are real world practical use cases for building knowledge graphs. And you might be thinking, Imtiaz, this sounds really geeky and complicated. Do I need to put on these geeky glasses? You don't really need to, my friend. The main thing you need to understand is that knowledge graphs are human and machine friendly. That means you can understand how your AI agent is making these decisions. It's explainable, and you can defend your agent in the court of law, compared to vector database, which is fast, cheap, binary, and machine friendly only. So you need something that lets you handle real world use cases and have dedicated time to client relationships. And what that means, all the updates happen automatically, zero manual updates, zero tweaking around with automations and RAG systems. You maintain relationships with humans instead of babysitting your automations or your databases. And the payoff is that you get your time back. Your agents work for you instead of you working to fix them. You build trust through transparency. Every fact has timestamps and source, and you scale without the chaos. The Graphiti memory starter template, so you can plug it into your Replit database and then plug it into your agent builder to create your own personal memory system that's production ready. Of course, make sure you like and subscribe to this video. I'm dropping new content every week so you can understand how to use Agent Builder, how to use Agent SDK, what it means to deploy to production, and also hit the notification bell so you don't miss a thing. Now we're going to use Agent Builder to build out our memory agent. It's just one agent setup, but you can quickly deploy this to production. I also covered this in my other video, just link in the description, where I talk about more what's the difference between Agent Builder, Agent SDK, and ChatKit. But understand with Agent SDK, OpenAI is handling all the backend session management and scaling for you. So you don't have to do all the cooking yourself. But if you do want to dive into the coding aspect, I encourage you to also work with the Agent SDK, which I'm also going to show you in this video. Now, obviously, OpenAI doesn't come pre-built with a knowledge graph or knowledge search feature. If you look at the tools, it only has file search, web search, code interpreter, and an MCP server. So in simple terms, the agent is going to have the prompt. It's going to have the LLM, which is the brain of the agent. And the last thing necessary here is the tools. So tools is interesting because you can use a lot of the OpenAI tools because OpenAI comes pre-built with file search, then it has web search, and it has code interpreter. Code interpreter allows OpenAI to basically run code, or agents to run code in its own sandbox, which is very powerful to create documents, presentations, or any kind of files that's needed, and that can be created with code. Now, this is the interesting part is MCP. MCP allows the agent to connect with external tools or databases, right? So this is how we're going to be connecting our knowledge search tool, right? Now, because it's external, we have more control over the database, over our own memory system. The agent just basically orchestrates all the tool calling. So what we've set up is our own server, MCP server, that has a bunch of tools in it, and it's connected to Neo4j graph database. So first things first, we have the prompt for the agent. It just provides a little bit of guidance in terms of when to store the message and when not to store messages, because we don't want the memory system to be activated all the time. We want it to be active when we're having meaningful conversation. But it helps for the agent to know that it needs to use the same session throughout the conversation. For every meaningful user message, you're going to add the message to session. Always search before answering questions. We're going to store personal facts, preference, skills, relationship. We're also going to search things about me, what's my job, before answering any questions, and also use stored when you're storing information, and when you're retrieving, make sure you use remember. Okay, so this should mimic natural conversation, and also we don't want it to disrupt our flow. And we're going to choose GPT 4.1 model. I found GPT 4.1 more versatile, and it's able to produce the schemas consistently and reliably to create these episodic memories for our knowledge graph. Now, obviously, you have the OpenAI native tools, which includes file search, web search, etc. File search allows you to search for information throughout documents. And you might be asking, why can't we just use this? The problem is, what it does is semantic search. It does not store relationships between entities across time. So even if you mark the journals with time, it's just going to retrieve specific portions of the text. So it's not organized or built for this kind of information. For this case, we are actually attaching our own custom MCP server. So we built the MCP server in Replit. Now you could use any coding platforms, Lovable Bolt. I'm going to give you the template so you can also plug and play. It is connected to a backend database called Neo4j. Neo4j allows us to store information in this kind of format, so it actually understands relationships of different entities, also tracks relationships over time. And obviously you can go through Neo4j graph database. They have a free plan for you to try and test it out. Obviously right now there's a lot of graph-based databases, so comment below if you want me to compare between the different graph-based solutions so you can know which one is going to be the right fit for your use case. They also have a self-managed version, so in this one you can host it yourself. but this would also include a lot of tweaking and back-end development work. So if you want to do that, you can definitely go with their self-hosted version. For this case, we're just going to use the cloud version and connect our AI agent with our own custom MCP server. So we're going to click on server. Now, if this is your first time running, the only thing you need to do here is put in your secrets. All the secrets can be found under Neo4j. If you go to query and then you go to instance, and then under connection details, this is where you're going to find connection details. Now, you know how to put in your OpenAI API key. It's easy to get it from the OpenAI platform. Once you have all that, you're just going to click the three dots right here. Click on open shell here. Opens up a shell terminal, and you're just going to say python main.py. And this is going to fire up our custom Graphiti MCP server. So we built our own custom Graphiti MCP server, but if you want to dive more into the Graphiti framework, what it does, what's the difference between GraphRag and Graphiti, you can go through the documentation. I'm going to list the resources in the description as well. So once this is running, you just have to click on the link where it's running and click on preview, then open this up in a new window. You're just going to do /SSE, and you're going to see this message right here with a session ID. So your MCP server is live. So you just go ahead and copy this link, go back to Agent Builder, and then you're going to plug in this link, knowledge server, my knowledge server. Okay, you don't need to worry about the access tokens here. Obviously, you can add authentication later. Now, congratulations, your agent is now equipped with a tool to store messages from sessions. Then it can end session, status, search nodes, get entity details, search memory facts, clear graph. There's a whole bunch of tools essential for working with knowledge graph. So we're just going to add these tools. We can go to console #preview.neo4j to actually look at the current state of the graph, right? This is loaded for demo purposes, but we can go back to our Replit server, open up shell here, and python clean.py. This is going to allow us to wipe the database clean. Now make sure you do it on a development database. This is obviously not for production, but this allows you to quickly test all the functionalities and make sure everything works. So we delete all, yes, delete everything. All right, so we're starting from scratch again. Now you'll notice the nodes and relationships have disappeared. You're starting from a blank slate. I'm gonna load the demo data again just so you can see how it looks like. Python demo.py. This is gonna load some data and show you some features of the graph. So it starts with creating entities, then it creates relationships. It also shows here how we invalidated information that have changed over time. For example, if a budget changed from 180 to 250, it will note that while still retaining the relationships and historical facts. So it will understand that currently the project has this budget, and also the project manager has changed from David to Kim, or whoever the new project manager. So it's going to understand what is the current state based on the time aspect. So our knowledge graph is ready to go. We'll go ahead and wipe the data clean once more, just so we can start over and show you how it works in the agent builder. So we're going to say wipe everything clean, delete all. Actually, we'll set the output format to text. So once everything is set, we just click on this and say, hello, my name is Alex. And so it understood that this is a meaningful thing to store. This approval box is good for testing purposes. Once everything is approved, you can then set it where it doesn't ask you all this details. But you can see here exactly what things are stored and the session ID, etc. So this is good for debugging. I live in Houston, Texas, and I love coffee. I'm gonna store this. All right, stored, you live in Houston, Texas, you love coffee. Let's see how it looks like in our graph. We're just going to click on this button. You see all the episodes and entities. Go ahead and click on relationships. You'll see the relationship. So we had 2 conversations so far, Alex, Houston, Texas, coffee. You see how everything is connected in our memory. Let's start another conversation. My name is Sarah. Stored, your name is Sarah. My friend is Alex. Store this in session. This is how the data is going to look here. So you see Sarah had a conversation, And also in the conversation, Sarah mentioned she's a friend of Alex. So you can see how it's connecting these memories together. Now there's a different ways you can go about it. You can assign user ID to specific users of this system, so it stores user specific graphs, or you could just create your own personal memory system. So this is meant for that. Now let's take a scenario where we invalidate some facts. And I do not live in Houston, Texas anymore. I live in Tokyo, Japan. Proof. Texas, and now lives in Tokyo, Japan. You can see now it's stored the fact that I live in Tokyo, Japan, and no longer in Houston, Texas in this conversation. Now let's go ahead and start up a new thread and say, I'm Alex. Where do I live now? Add message, search nodes, live in Tokyo, Japan. You previously lived in Houston, Texas. You can see now that the agent understands these temporal relationships, how things have changed from one point in time to the other. Once you've done a few rounds of testing here, you can go back to the knowledge server, and then you go ahead and say, I do not need approval. Click on update, and then click on publish. So now it's production ready. It's good to go. Now, if you want to deploy the knowledge server, just click on publish, then you're going to get a new link to this knowledge server, and you're going to go ahead and update the knowledge server link here with the published deployed link. Okay, that's the only change that you need to make. Now let's go ahead and search through the database again. Tell me what you know about me. As you can see now, it's automatically going to search through. Remember, you're Alex, who previously lived in Houston, Texas, and has relocated to Tokyo, Japan. Also, you love coffee. If there's anything you'd like to add or update, just let me know. Okay, so the memory system is fully functional. You might be asking, well, Imtiaz, this is great, but what if instead of knowledge search, I use file search? In another video, I'm going to compare between file search and knowledge search and how it performs in real world use cases when you have a large corpus of text. I want to quickly walk you through the different workflows when we're dealing with file search and knowledge search. So you have an ingestion workflow, and then you have a retrieval workflow. And these two workflows are pretty common RAG pipelines. Now here's what's different in traditional RAG versus what we just built. In traditional RAG, your data goes into embeddings, gets stored into vector databases, and you search with semantic similarity. It's simple, right? But here's the problem. It's binary. It's human unfriendly. When something goes wrong, and it will, you'll be staring at arrays of floating numbers. Good luck explaining that to your clients. Then you have GraphRag, which is also quite common, and it goes a little bit more sophisticated. So it takes the unstructured data, so any data you can think of. So let's just take a scenario where you have a sentence like this, right? It's going to take that data, and then it's going to chunk it, and it's going to feed it through some ML models, right, to extract the entity and relationship. So it's doing a little bit more to derive meaning, squeezing out that sauce from the data. Now with this kind of format, you can easily see the entities, you can easily see how they're connected, one information, how it's connected to another information. This is easily debuggable, it's easily explainable to the stakeholders. The next level up is the temporal knowledge graphs. So just like vector database where it takes unstructured data, chunks it and all that, and just like GraphRag where it extracts entities and relationship, it also stores time. Goes to the ML model, and then you have a knowledge graph with the time aspect to it. And so this makes it human and machine friendly. When you explore the data, you'll see that it has graph format, which is obviously human friendly. You can look at the nodes and relationships, how everything's connected. In the back, you also have the vector embeddings. Just like a vector database has the vector embeddings data, you also have this. So it has the benefit of the semantic search capability that vector databases have. Now this is where it gets really interesting, is the retrieval speed, because temporal search is actually faster. Graph search is fast and vector search is actually slow. You're searching through everything every time with vector database. So let's say you have a book and you fed the whole book into the databases and you want to understand who's the main character in the book. Vector database is going to search through all the embeddings, rank by similarity, very slow. GraphRag, it's going to search characters wizards relationship very fast, and temporal graphs, it's going to search characters, plus it knows who was introduced when, so it's faster. Plus you also get to time travel. You can ask who's the main character 30 days ago. Traditional systems can't answer that. Okay, so for my developer friends, we have put together an Agent SDK startup guide for your personal memory agent. And the great thing with this implementation, it tracks whether facts are valid or invalid at a specific point of time. A lot of temporal graph solutions do not have this. So we've taken inspiration from the Graphiti open source framework and built this notebook out. So you could practice this and build out your own memory agent. We're going to install a couple of packages here. So when you run this, it's going to install OpenAI agents, which is the OpenAI agent SDK framework. Then you have Neo4j, which is the database. And then we have OpenAI for plugging in our LLM, where we get to use the intelligence from GPT 4.1, and Gradio is going to be our chat interface. So once that is installed, we're going to click on secrets. Now we're going to make sure Neo4j credentials are plugged in securely in Google Colab. Now this exists in your environment, so it's not shared with public. Close the box out. You can run this cell. All right, so once things are loaded, you'll see that all credentials are loaded. Perfect. Now we are going to import the libraries. This is good. Now the next step is we are going to connect to our Neo4j database. Current memory in the database 5. So this is the 5 existing memories we've already worked on so far. So we can go ahead and also delete it if you want. Step 5 is the temporal database schema. So we're going to set that up. It's going to create the custom schema, which allows us to put in the nodes, relationships, the temporal fields, define how things are going to be stored. You'll get all the details right here. Step 6 is going to be the memory helper functions. We're going to run this. And again, all this is going to be in the link below. So if you want to grab the template, go ahead and use it for your use case. We're also hosting a few workshops if you get stuck and need extra help. We have a community of builders who are also working on the same thing. So if you want to come check us out, I'm going to leave the link in the description so you're not alone in your journey building these solutions. All right, so we're going to define the tools here. So the tools are going to be pretty straightforward. We're going to add message to session. Then we're going to search entities, query facts at a time. The great thing with Agent SDK is that you have a tool decorator, so which makes it really easy to develop these tools and keep it modular and organized. So once all the tools are loaded, you can go ahead and create the memory agent. It will come with the critical rules as we've used in our agent builder. We're going to use GPT 4.1. GPT 4.1 performs better when it comes to creating JSON and custom schemas, etc. So you can see memory agent created, and then you have the available tools. So we're going to test out the agent, but before we test the agent out, we're going to go ahead and clear the memory, right? So just so we can show you the demo and how everything works from the Agent SDK perspective. We've cleared the memory, and then we're going to go ahead and test the agent. So phase 1, it's going to set up the initial state. So what that means, we want the conversation to persist throughout the state, and the episodes should capture all the things that have been talked about. So in this case, if we store something like, your name is Sarah, 30 years old, live in London, work in Google as a product manager. So it's going to extract these entities, Sarah, product manager, she lives in London, all this kind of stuff. So it breaks it down into these structured relationships. Phase 2, we have a scenario where Sarah changes her location. She moves to New York from London. What that means, we can correctly say that Sarah lives in New York because we have the timestamps on the data points as well. If we have a scenario where she makes a change in companies, then we can also capture that as the current state. So phase 4, we're verifying the current state. You are Sarah, 30-year-old individual, currently living in New York, having recently moved from London, blah, 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 your personal info. This is the 5th test, is time travel. What was true earlier? So this is important. If we change facts about ourselves, like, hey, we moved to New York, we also don't want to forget that we used to live in London. So things like that. Now, the test 4, we're going to verify the current state. You can see the agent remembers that she's Sarah, 30-year-old, currently living in New York, moved from London. You see the old facts haven't been deleted from the database. It knows that London was the earlier location. Through this test, we have demonstrated how the agent retrieves specific facts or information that has the time component with it. Historical facts are preserved, they're not deleted, so agent will not hallucinate when things change. Old facts are still valid, except they're old news, and the agent knows that. And then, most importantly, we have a complete audit trail of things that have been maintained. So the key insight here is that Sarah moved from London to New York, Google to Meta. The old facts were invalidated, not deleted. We can still see her entire history. We also have a section where you can load demo data, just like we did in our agent builder showcase. So we'll just skip right to step 12, where we're going to just launch the Gradio chat interface. So Gradio is actually pretty good to prototype chat interfaces with very low code. For the final build, you can always use ChatKit or build up your own chat experiences and put the lipstick on top of it. But as you can see, this is a good way to prototype. Agent Builder also is good with the chat interface. If you want to take one step further, use Agent SDK with ChatKit. That gives you full control and you can manage it in your own servers. Another thing with Gradio, you can share this link to potential clients and also deploy this in Cloud Run for a permanent interface. But already we can do so much with it. We can say, tell me about me. So here's what I remember about you based on my search. Your name is Sarah. You're currently employed as a product manager. You've been associated with Google in the past. You have professional expertise. You recently moved to New York. There are past connections to San Francisco and London as well. All right, so as you can see, it was able to search through the knowledge and give me this accurate information. And obviously, you can also look at the graph and see how things are stored, how every session is connected, how every entity is related. All this information can be traced back and it's there for you to audit. Hopefully this clears things out and you understand when to use these knowledge systems. This level of technical sophistication is what separates the Vibe Bros from production engineers. If you're building AI systems for clients and they're failing in production, this is why. Now, if you want to dive a little bit deeper into temporal knowledge graphs, make sure you watch this video. I go more into the concept. Cynthia signing off. Peace.